Hello and welcome all of you to the first session of crash programs of uh, virtual classes of science here. And here I am Shabu Subramanian. Here we are going to start with the motion along a straight line unit, and in this session we will do the problems related to velocity and acceleration, especially the questions related to instantaneous velocity and acceleration. So first problem is, when there is a problem is given in a question paper or in an entrance paper, how to identify whether that is related to the concept of instantaneous velocity and acceleration. So I'll tell you the first. So whenever there is a problem in a paper, just like if you have got an expression in that one, what I mean by an expression, a relation. Say suppose x is equal to say 3t square plus 2t plus 6. This is a quadratic expression, we can say, or there can be a linear expression. So whenever there is a relationship expression or an equation which is given in a question, it is straight away an indication that it's a problem related to instantaneous. You will see many examples after this brief discussion of the theory. So first of all, I want to tell you how to identify the problem. In order to identify the problem of instantaneous concept, you just check in a question whether this kind of or any kind of expression, say velocity is equal to say t square plus 2t plus something, acceleration is equal to x plus 3t. If such kind of expression or equation is given, that is a clear indication that that problem have to be dealt with instantaneous concept. So what are the concepts of instantaneous relationships or instantaneous velocity and acceleration? So we are into that one. Okay. So the instantaneous problems or instantaneous concepts are all related to x, v and a. We know what is x, which is the displacement or the position vector. V is the velocity and A is the acceleration. So I will give you a couple of differential relationships and a couple of integral relationships. In order to study the instantaneous concept, we have to learn few differential relationships and few integral relationships. So what I mean by this? These problems are completely based on calculus. We have to do differentiation or we have to do integration sometimes. So the first one is v is equal to dx divided by dt, or we will say v of t. What is v of t? Velocity at a particular time or instantaneous velocity is defined as the first differential of the position vector. First differential of the position vector. And second is acceleration. A of t is equal to dv divided by dt. So what is that? Instantaneous acceleration is the first differential of velocity. So velocity is the first differential of position, and acceleration is the first differential of velocity. We can extend this one as d by dt of dx by dt, or that is equal to d square x divided by dt square. So we have seen 3 points from this. Velocity is the first differential of the position vector. Acceleration is the first differential of velocity vector. Also, acceleration can be said as the second differential of the position vector. So, how many questions you can immediately say? 1, 2 and 3, or 3 concepts we have learned right now. Which are the first differential of position gives velocity. First differential of position gives velocity, exactly. And first differential of velocity gives acceleration, and second differential of position gives acceleration. So these concepts are related to the differential aspect. Now the next one is integral aspect. What is integral aspect? As v is equal to dx by dt, I can write x is equal to integral v dt. Integral v dt. That's the first integral relation. What is that? That means we can find the displacement by integrating velocity on time. We can find displacement by integrating velocity and time, say maybe from time t1 to t2. That will give you the delta x, x2 minus x1. And next one is second relation, as a is equal to dv by dt, we can have v is equal to integral a dt from t1 to t2. This will give you the change of velocity. So we have seen two integral relationships which are useful to us. That is, displacement is the integral of velocity on time, and velocity change is the integral of acceleration based on time. So this much is required for us to start with the questions. So here I have written the first problem of instantaneous, or the problem instantaneous velocity and concepts of acceleration on the board. You can just note down the question. What is given over here is the motion of a body along a straight line is represented by x is equal to 8 plus 12t minus t cube. The retardation of the body when its velocity becomes 0 is option A is 24 meter per second square, B is 0, C is 6 meter per second square, and D is 12 meter per second square. So all of you have to note down this problem. Let us see how to start with the problem, how to start the solution. See, this is the first question, that is why I have written it in detail. Next time onwards, I will be making it short as much as possible so that we can be able to solve it, or we can save some time. Okay. So, in order to start with the question, what is my first striking point? As I told you, just look at the problem. I have got a relationship which is x is equal to 8 plus 12t minus t cube. That indicates what? This indicates that this problem is related to instantaneous velocity and acceleration. As I told you, there is a relation. Okay. Now, for any entrance exam, what I suggest you is, don't go into the question, okay, or don't go to the head of the question. Start from the tail of the question. What is a tail? Problem is to find out the retardation when the velocity becomes 0. So I have got two inputs instantaneously. What are they? I have to find the acceleration or retardation, whatever it is, when the velocity is 0. So my striking point is the velocity becomes 0. At that time, what is the retardation? Okay, or minus a. I have to find minus a. Okay. Now let's start the solution or the solving of the problem. So this is the relationship which is given between x and t, or I can write this one as representing instantaneous position. From the instantaneous position, I can derive instantaneous velocity. What is instantaneous velocity? That is dx divided by dt. Differentiate that. I'll get 8, the differential is 0. 12t, I'll get 12. T cube, that will give you 3t square. And what is acceleration? I'll find acceleration. What is acceleration? That is dv divided by dt. Differentiate this one again. 12 differential will go to 0. 3t square will give me minus 6t. Your problem is, what is the time at which v becomes 0? So use this one, equate this one into 0. That means velocity when it becomes 0, what is the time? Solving this, I'll get 3t square is equal to 12, or t is equal to, that is 12, t square is 12 by 3, that is 4, t is root 4, that is equal to 2 seconds. That means when the time is 2 seconds, velocity of the particle is 0. So substitute that one over here. I'll get a of t is equal to minus 6 times 2, that is minus 12 meter per second square. Your question is, what is the retardation? So retardation is minus a of t, which is equal to 12 meter per second square. So you got the answer for the question. So the previous one was an example of a differential type of question. Now we are into the next question, in which is given like v is equal to a plus bt square. Question is to find distance traveled between two time intervals. Problem is to find distance traveled when v is given as an expression. Expression is given, this is based on instantaneous concept. And how we can find out the distance traveled? We know distance traveled x is equal to what? Or we will call it as delta x even. It is integral t1 to t2 v dt. Substitute t1 is the first times 1 second and t2 is 2 seconds. t1 is 1 and t2 is 2. v is a plus b t square dt. This is just an integration process only and substitution. This is an indefinite integral because okay, we will substitute all the values. Integral t1 is equal to 1 to t2 is equal to 2. A dt will give you at plus bt square divided by 2. So we have got at plus bt square, bt cube divided by 3. T square integral will be t raised to 3 divided by 3. A integral will be at within the limits 1 to 2. I'm sorry, this is a definite integral because we have got the limits. Okay, this is 1 to 2. So substitute the limits, you will get the value of delta x as, first one is 2, so that is 2a plus 2 cube is 8, so 8 by 3 into b minus substitute 1 or put the lower limit 1, so a into 1 is a plus b into 1 by 3, so plus b by 3. Now just rearrange. 2a minus a is a, 8 by 3 minus 1 by 3 is 7 by 3. Look into the answer, we have got 3a plus 7b. So take 3 to the side, we'll get 3a plus 7b. That is the right option. We got the third problem. Question is, acceleration of a body starting from rest is given as a is equal to 3t plus 4. Obviously, there is an expression, it's an instantaneous problem. Question is, velocity at t is equal to 2 seconds. Problem is to get the velocity when the acceleration is given. Problem is to get velocity when the acceleration is given. It is given that it is initially at rest. So that means when t is equal to 0, u was equal to 0. We have to get the velocity. What is the expression for velocity? Velocity is integral, say 0 to the final time 2 seconds a dt. We know that velocity can be found as what? Integral of a dt. This can be written as v minus u or change in velocity, as I told you. This is delta v. So delta v is v minus u is equal to integral 0 to 2. A is nothing but that is 3t plus 4 dt. Just to check whether you know how to integrate. Okay, this is very linear relation and it is very easy to integrate. That will give you 3t square by 2. T integral is t raised to 1, t raised to 2 divided by 2 plus 4t within the limits 0 to 2. Substituting the limits, what you will get when you substitute 2, this will become t square and t. So t square is 4, 4 into 3 is 12, 12 divided by 2. So I'll show the substitution also for those who have got some doubts. v minus u is 0, so I can write this one simply is equal to v is equal to 3 into 2 square divided by 2 plus 4 into 2 minus lower limit is 0, so thus all term will become 0. 3 into 2 square is 2 square 4 into 3 is 12 divided by 2 is 6 plus 8, this is 14 meter per second. Our right option is C. That's it. We are into the next question, which is given. It is a long question. You have two cars P and Q starts from a point at the same time in a straight line, and their positions are represented by two expressions. xp of t is equal to at plus bt square and xq of t is equal to ft minus t square at O. That is the given situation. Question is, at what time do they have the same velocity? Options are given as a minus f divided by 1 plus b is a plus f divided by 2 into b minus 1, c is a plus f divided by 2 into 1 plus b, and d is f minus f divided by 2 into 1 plus b. It's a very simple question actually, doesn't look like as complicated as the expressions. So just note down this. So you can see two expressions are given. I have given with this expression and this expression. So problem is based on instantaneous. Question is at what time? So this is the question, time at which they have the same velocity. At which they have the same velocity. So we are going to solve this problem. Okay. So it's a typical entrance question. I am starting from this point. They have the same velocity. What does that mean? Velocity of P is equal to velocity of Q at a particular time. How to get velocity of P? Velocity of P is Vp of t is equal to dxp of t divided by dt, and velocity of Q is dx that of Q divided by dt. So differentiate the given expressions and equate them. These two are equal as it is given. Differentiating this, at plus bt square will give me a plus bt square differential is 2bt. So this is velocity of P. This is given as equal to velocity of Q, which is equal to, differentiating this, ft will give me f minus 2t. So I've got the expressions. Now equate them. A plus 2bt. So I've got a plus 2bt is equal to f minus 2t. Collect the terms of t. This will become t into 2b plus 2, which is equal to f minus a. Write the expression for t. T becomes f minus a divided by, so we can take 2 outside, 2 into b plus 1 or 2 into 1 plus b, whatever is given in the expression. That's the solution. Moving on to the fifth question now. Here the problem is given like a particle of unit mass undergoes one-dimensional motion such that its velocity varies as v of x is equal to beta x to the power minus 2n. The acceleration as a function of x is given by, options are minus 2n beta square x raised to minus 2n minus 1. Option B is minus 2n beta square x to the power minus 4n minus 1. Option C is minus 2 beta square x to the power minus 2n plus 1. Option D is 2n beta square e to the power minus 4n plus 1. So the problem is clear. We have got an expression. We have to find the acceleration as a function of x. Acceleration as a function of x. As a function of x. So you can note down the questions and options. We are going to see the solution. Okay, just look at the problem. So our problem is to get acceleration. We all know that acceleration is the first differential of velocity, dv divided by dt. But look at the expression of velocity. Velocity is given as v of x is equal to beta x to the power minus 2n. That means velocity is a function of x. So our velocity is expressed in terms of x, not in terms of t. So I need to get x as a variable over here. What I can do is, I will write this one as dv divided by dx multiplied by dx divided by dt. Now this becomes simple for us because we have got dv divided by dx. We can find that one from here. And dx by dt. What is dx by dt? Dx by dt is nothing but that is velocity. This is velocity itself. Now let us proceed with dv divided by dx. What is dv divided by dx? dv divided by dx. Differentiating this with respect to x. X to the power minus 2n will become minus 2n. Beta is a constant. X to the power minus 2n minus 1. Or I can write this one as minus 2n beta x to the power minus 2n minus 1. Substituting in this expression, my acceleration becomes, say I am writing this side, acceleration is dv divided by dx times dx divided by dt. What is dv divided by dx? dv by dx is this one. So that is minus 2n beta x to the power minus 2n minus 1 dx by dt. What is dx by dt? That is velocity. That is again beta x to the power minus 2n. Beta x to the power minus 2n. Just combine that two terms. Minus 2n beta times beta is beta square x to the power minus 2n minus 1 multiplied by x to the power minus 2n. We can combine that two. You will get minus 2n minus 2n minus 2n minus 1 and x to the power minus 2n. This will become minus 2n beta square x to the power minus 4n minus 1. Look at the options which are given. Which will be the right option? We have got the option B as the right one.